Hi everyone, today we are going to talk about 7.0b, simplifying rational exponents, second part, part 2. So we learned what is a rational exponent and also how to simplify them last time, right? In the last lesson. Then, so today we are going to simplify same thing, rational exponents, but now it'll be a little bit more complicated. But it's not complicated, a little more steps, right? Before we do it, we need to know how to do the prime factorization. You learned this in the junior high school. You know what is a prime factorization and how you do it, right? So let's try. Prime factorization is finding which prime numbers multiply together to make the original number. So you rewrite the original number with the prime numbers. Prime numbers. That's a prime factorization. So how do you do it? So prime factor, let's do the prime factorization of 48. Right? What is the step? First step. You remember 48? 8 times 6 is 48. But if you remember, if you can use other numbers, okay? Other pairs. Instead of 8, 6, you can do the what? 2 times 24 is all right. Eventually, you will get the same result, right? Now, 8 and 6, they are not prime numbers. Then you should keep doing it. 8 is what? 2 times 4 or 4 times 2. And then 2 is prime number. So we change the color here, or you can circle it. Then 4 is not prime number. Then you should do that again. 4 is what? 2 times 2. So 2 are prime number. How about 6? 2 times 3. Then there is no more to do, right? So how many 2's are here? So 48 is equal to 2 times 2 times 2 times 2, and then times 3. Right? If you multiply everything, it becomes exactly the same with 48. But instead of you writing like this, 2 times 2 times 2 times 2, what is it? 2 to the fourth power times 3. You can simply write down like this. This is the prime factorization. And then we'll combine this prime factorization with last lesson. And that's it. All right. 72, you can practice. 8 and 9. And 8 is to the third power. And 93 squared. That's a prime factorization, right? Now, let's simplify these rational exponents. Before, so look, we have 72 number and variable, two things in the parentheses as a product form, right? Product means multiplication. If it is addition, you cannot do anything. Addition or subtraction. And 3 over 5th power, you cannot do anything. But it's a form of multiplication, or division is similar to the multiplication, same thing, right? So if it is product with a number and the variable, and outside you have a rational exponents, then what can you do? You should simplify. But before you simplify, do you remember what we did for the number 72? Yes, we changed this into the form of prime numbers. So we do the prime factorization. So we just did what is 72, right? 72 was 8 times 9, and then 2 to the third power, 30 squared. So we are going to rewrite. So first step is prime factorization, and then rewrite like this. 2 to the third power, 30 squared is equivalent to with 72. And then x to the fourth power, and 35th. And then what do? You multiply the power to every single thing in the parentheses. And you multiply power to the other power, all right? Powers in here. Do not multiply 3 over 5 to the number 2 here, like not 3, like you multiply this to the power of each term. All right. So 3 times 3/5, 2 times 3/5, 4 times 3/5, like this, which is 9/5, 6/5, and 12/5. And then we are going to change it back to the what? Radical form again. But how do you change it? Do you remember? This rational exponents, if this is a mixed number, improper fraction, we change them into mixed number, right? So 9/5 is 1 and 4/5. Like this is 1 and 1/5. This how many 5 in 12? 5 times 2 is 10, right? So 2. And what is the leftover? The remainder is 2. So 2 and 2/5. That way you need to change the convert improper fraction into the mixed number. All right. If it is a mixed number, what did I explain before? This is like 1 plus 4/5. Then we can separate into the 2 to the 1 power and 2 to the this rational fraction part, right? So we can separate everything. So let's separate 2 to the 1 power. 2 to the 1 is here, and 3 to the 1 is here, x squared here. Because everything is a multiplication, you can change the order, doesn't matter, right? So I put the integer part, that if the exponent is integer, I put them all in the front. So 2, 3 to the 1, x squared in here. And then, can you remember 2 to the, now what is left? 2 to the only the fraction part, right? Because integer part is moved away to the front part here. Now, we are thinking about only 2 to the 4/5 power, 3 to the 1/5 power, x to the 2/5 power. Everything is 5th power, right? Then, so you will have always same denominator, because you are going to use a common denominator anyway, right? Common denominator. So you are going to put, when you change the rational exponent into the radical form like this, the denominator go to the outside here, which root, right? 5th root. And then numerator become the exponent of each base. Do you get it? So because you have all same radical, which is a 5th root, you don't need to put all separate the 5th root. You need only one radical, which is now 5th root, and then 2 to the 4th power, 3 to the 1 power, x squared, like this. And then what do? You simplify now. 2 times 3 is 6. 2 to the 4th power is what? 2, 2, 2, 2, which is 16. 16 times 3 is 48, right? Right. So you can rewrite. This is a final answer. Even though there are many steps, if you understand how to convert, how to multiply power to power, right? And how to change rational exponent to the radical, or radical to the rational exponent. And then that's it. All right, can you try with this one more time? We have a error analysis here now. So Veronica did a mistake. What is the mistake here? So before you do this, she did a prime factorization for 8, 2 to the 3rd power is okay, and then separated the negative. Negative is like a -1. You can consider negative as a -1, doesn't matter, right? But let's separate negative as one term. Separate it. Negative 2 to the 3rd x. Now, what do? You do the power to the every single thing, right? 4 over 5, 3 times 4 over 5. X has a 4 over 1 times 4 over 5. So far, so good, right? And then what happened is, so 12 over 5, we change it to the 2 and 2 over 5. Improper fraction, you change it to the mixed number. The others, all is okay, right? So 4 over 5, 4 over 5. Now, we are going to change it back. Everything has, now 2 square will be sent away to the front, right? 2 square is a 4, it's okay. Only this is a mixed number. So 2 square will be go in front of the radical form. And then as we know, 5, 5, 5 is the 5th root, right? 5th root. So everything will go into the one radical, which is 5th root, right? But what is the mistake? Where did you get the negative here? 2 square is positive, right? But this negative go into the 5th root with a negative 4th power. It should be in the radical form, not outside here. Do you get it? Oh, so that is the mistake. Let's see from here. So 2 square goes out as 4, right? But now everything negative 2 and x, they all have the denominator, the rational exponent, and then the denominators are all 5. So we use 5th root, right? And then the rest is negative to the 4th power go inside, 2 to the square go inside, x to the 4th power go inside. But we switch the order. Is it wrong? No, it's a commutative property. Even though you switch the order, it's okay. So then that could be a trap. But you understand. So negative 4th power, negative to the even number power is positive. Negative to the other number power is negative, simply, right? So negative, 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 negative. You multiply 4 times. If it is paired, then it becomes positive, right? Negative, negative is positive. So negative even number is always positive. X to the 4 and 2 squared is 4. So now we put the number first, 4x to the 1st power. And then this is the answer. Okay, that's it. We'll stop here. Everybody understand, right?